What's up, fourth graders? This is a recap of Illustrative Mathematics Unit 3. This is going to be a video reviewing the study guide that you received either today or you will receive soon. And I will be using the strategies that you find on your study guide answer key. All of these strategies are things we have done in class. They are things that we have talked about. They are things that we can reason through in our minds to come to the correct conclusion. So, as we begin to prepare for our Unit 3 test, enjoy this video showing you how to complete your study guide. So, stick around. Alright, so on your Unit 3 study guide, page 1 is a review of Section C. Section C hits at the very end of the unit, and we just talked about it just recently. So number 1 says select all expressions that are equivalent to 53 hundredths. What we can notice right away is that on all of these choices, we have tenths and hundredths, hundredths and tenths, tenths and hundredths, tenths and hundredths. We have multiple add-ins here in the bottom. What we need to make sure that we are working on is finding that common denominator. Common denominator is one of our vocabulary words. A common denominator is when you have two denominators are the same. These two denominators are not the same, so we cannot add these things together. We have permission to change any fraction at any time to get us what we need. So what we are going to do, we are going to take this 3/10 and we are going to change it into something that's more valuable for us. So I'm going to come over here, and we know to find an equivalent fraction from Unit 2, we can multiply any fraction times 1, which in this case we're going to choose 10/10, because any fraction that has a numerator and a denominator that are the same is the number 1, right? 3 times 10 equals 30. 10 times 10 equals 100. Now, this 3/10 is now 30 100ths, and we can add 30 100ths plus 5 100ths. That gives us 35 100ths, which is not what we are looking for. What we are looking for is 53 hundredths. So A is not the correct choice. We are not going to select A. And we are going to go through all of these questions and do that same thing. Again, hundredths and tenths. 50 hundredths, I'm going to have to move this over here. 50 hundredths plus 3/10. Well, again, oh, look how handy this is. See? I can't use 3/10. I'm going to change this 3/10 to 30 hundredths. Now that I have 50 100ths plus 30 100ths, I know that based on basic fraction addition, my numerator and my numerators go together, so that gives me 80, and my denominator always stays the same, because remember, we're not changing the size of the piece, right? All right, so this is 80 hundredths, so that tells me that B is also not my answer. Now I'm going to very carefully check the last three. Tenths and hundredths again. So 5/10 and 3 hundredths. So 5/10, I'm going to bring this over here. 5/10 over here. We're going to turn that into, multiply it by the number here, the 1, and that's going to get us 50 100ths. Plus the 3 hundredths, which we can just bring over. 50 plus 3 is 53, and my denominator stays the same because I'm not messing with the pieces. I'm not changing the pieces. What I've actually done to these tenths is I've just taken these tenths, cut them up into hundredths even more, taken each 10, like the picture we saw today, tenths, that was a 10, this is a 10, cut that up into hundredths, and now I have 53 hundredths, which happily is a match. So I am going to choose C. And you would do the same thing for all of these. One thing we did learn is that, let's see here, 1/10, 4/10, 3 hundredths. 1/10 plus 4/10 plus 300ths. Again, I'm just going to bring this over here. I'm running out of space, as you can see. One thing that we learned today is that our third grade teachers did a really great job of teaching us, I'm going to write this up here, that 3 times 10 equals 30. We know that. And because we know that whenever we add a 0 to any number anywhere, we're just adding a 10. So 4, put a 0 on the end of 4. We've added that, we've made it into a 10. Now it's 40. We can do that same thing over here. Because we know this right here, we know all of this, we don't have to go through all this all the time. Although I did show you all the work on your answer key right here, the paper that you got. I did fill in all of this work and showed it to you step by step. What you can do now is you can just add that 0 on there. You know that it's a 10, and you know that whatever you do to the bottom, you must do to the top. I wanted to give you time to say that. 10 hundredths, 40 hundredths, 3 hundredths. 10 plus 40 is 50 plus 3. Ta-da! 53 hundredths again. There's another correct answer right here. And then for E, I'll let you look at your study guide answer key or let you figure that out on your own, as you can see. So now that is how you do that. So now all you have to do is find the value of each expression. Let's make a list of brainstorming ideas. What's the first thing you're going to do? The first thing you're going to do always is look at the denominator. That's what you have to do, because what do you have to have? You have to have common denominators. You have to have a common denominator. So the first thing you need to do before you even begin these things is look at that denominator and see if you're good. 100, 100, 100. We're good. Now all we have to do is add up the 19, the 26, and the 1. 19 plus 1 equals 20, and then 20 plus 26 equals 46 hundredths. We didn't have to do any work because we had our common denominator already. After you've looked at the denominator, made sure you had a common denominator, then you can perform the operation, whatever it is they're asking you to do. There may be other steps in here too for other things we'll do later in this video, so stay tuned. Same thing down here for B. Look at that denominator. Tenths, tenths, hundredths, row. So what I'm going to do is I'm going to write this down here. 4 tenths plus 3 tenths plus 18 hundredths. And I know that I have to have common denominators. So this is 100. I'm going to go ahead and just turn these into hundreds. Whatever I do to the bottom, I must do to the top. And so then I'm going to have a 0 here and a 0 here. Going to add these things up, and they are going to total 88 100ths. That is how we use common denominators to add tenths and hundredths together, making sure we have that common denominator and only changing our numerator, not our denominator, to collect these proper, correct answers. All right, this is the second page of your Unit 3 study guide. This is from Section A. In Section A, we were talking about multiplying whole numbers times fractions. Unit fractions, which is right here. A unit fraction is any fraction that has a what? I hope you're answering these things whether you're in your room or on your couch or at your kitchen table. A 1 as the numerator, so 1/8. That would be a unit fraction, right? So we are multiplying whole numbers, which is whole things, by unit fractions. We have a new rule in the 4th grade. This little symbol right here. I'm going to make some notes over here. This little symbol right here, instead of saying times, which we always have said, what do we say? We say groups of. This is going to really help us think about what we're doing here. So when I say 5 groups of 1/8, I am literally going to make 1, 2, 3, 4, 5 groups, and I'm going to put 1/8 in each group. It's really hard to write this small. 1/8. So I have, and now I'm just going to count them up. 1/8, 2/8, 3/8, 4/8, 5/8. 5 groups of 1/8 equals 5/8. Now, we made one critical error when we first started this. We did not read the question. Select all expressions that are equivalent to 8/5. Is 5/8 equivalent to 8/5? No, it is not. That is not our answer. Now, our next question. I'm going to go ahead and start moving over here again. 8 groups of 1/5. 8 groups of 1/5. I could write this out too. 1/5 plus 1/5 plus 1/5. I'm just going to keep on going. Plus 1/5 plus 1/5 plus 1/5. 1, 2, 3, 4, 5, 6. How many do I need? 8. 6 plus 1/5 is my 7th one, plus 1/5 is my 8th one, equals 1, 2, 3, 4, 5, 6, 7, 8. 8/5. As you can see, all I am doing when I am multiplying whole groups by fractions, 8 groups of 1 is 8, and my denominator stays the same. My denominator stays the same because we're not changing the size of the piece. There are times in the 4th grade when we do change the size of the piece, kind of just like we did on page 1 of the study guide. When we're finding an equivalent fraction, we have permission. We are encouraged. We actually need to change the size of the piece, but not right now. There's nothing to change. 8 groups of 1/5, 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 8/5. It is a match. So we are going to circle B. Next, now this changes a little bit. Now we no longer are using unit fractions. We just have regular fractions. So 2 groups of 4/5. I am going to pull this right here because it's only 2 groups. 2 groups. I just drew 1 group. 2 groups, that's what that is, of 4/5 in each group. Now I have 4/5 and 4/5. If I have 4/5 here and I have 4/5 here, how many fifths do I have all together? Well, 4/5 plus 4/5 would be 8/5. I have 8/5 when I have 2 groups of 4/5. So that means C, 8/5 here, 8/5 here. We're a match. We're going to circle C. Very nice. And D. I hope you guys are seeing this as a pattern here, right? Let's do this one this way. 2/5 plus, how many groups do I need? 4 groups of 2/5. Remember, we say groups of. We do not say times, because groups of just helps us keep our mind straight on what we're doing, right? 2/5 plus 2/5 plus, there's my 4 groups. 2/5, 4/5, 6/5, 8/5. 8/5 is my answer. 8/5 is a match here and a match here. Circle for D as well. And finally, let's see what we have going on here. Read it with me. 2 groups of 6/5. 2 groups of 6/5 in each group. 2 groups of 6/5, that would, and this is plus, obviously. Oh, well, it is plus because it's repeated addition. It's times multiplication. So we're adding these things together because we have 6 times 2, 2 sixes, 2 sixes. 6 and 6 is 12. 12/5 is not a match, so we do not have that. Now, number 3. Draw a diagram showing 4 groups of 2/5. My students should recognize this. We actually did this paper. We can use circles. 4 groups, 2/3, excuse me, with 2/3 in each group. This would be a great diagram. This shows that we have 4 groups, 1, 2, 3, 4, and that we have 2/3 in each one. My students are so good about drawing diagrams with tape diagrams like this. We would have 4 holes. 1, 2, 3, 4. Cut all of them into 3 equal pieces. So now I have 4/3. And then we would just color these in. So 1, 2, there's one group of 2/3. 1, 2, there's two groups of 2/3. 1, 2, there's three groups of 2/3. 1, 2, there's four groups of 2/3. We could do that. I have students this year who love a number line. We haven't had that before. And so my students might draw a number line like this, and they would draw it like this: 0, 1, 2, 3, 4. And they would do this. And they would go maybe 2/3, 2/3, 2/3, one group, two groups, three groups, 2/3, and land right here. Might do something like that. Or we could just do it straight. We could just do it like this: 2/3 plus 2/3 plus 2/3 plus 2/3. I will tell you, the number line strategy is not on your answer key. That's okay. It still works. You can use whatever strategy you want. It doesn't have to be on the answer key. You can draw this you could draw this however you wanted. You could do 2/3 like this. As long as it's four groups, so here's 1, 2, 3, 4. As long as it's four groups and you have 2/3 in each group. 1, 2, 1, 2, 1, 2, 1, 2. You could. This is also not in the diagram or in the study guide answer key. Your study guide answer key kind of looks like this. Give you a little screenshot opportunity here. And then based on all of these diagrams, we know that the total amount of thirds that we have, four groups of 2/3 equals 8/3, because 2, 4, 6, 8, 1, 2, 3, 4, 5, 6, 7, 8/3. And so we have 1, 2, 3, 4, 5, 6, 7, 8/3. So this concludes our discussion of the study guide on page 2. Again, this is from section A in your Illustrative Mathematics Unit 3 workbook. All right, so here we go. This is the last page of your study guide for your Unit 3 test, which is coming up soon. This is the section B of your workbook. This is where we were talking about addition and subtraction of fractions. And so we talked about some brainstorming ideas for addition and subtraction of fractions. And so we have brainstormed these ideas. And so I just want to jot these down for you. Number one, what is the first thing we do every single time we are going to do some sort of operation with a fraction? We are going to look at that denominator. We have to know and make sure that our denominators are what? They have to be common denominators. That is key. If we do not have common denominators, we're in big trouble. We have to have common denominators. The second thing we're going to do is we are going to study the expression. We're going to look at the expression, decide what exactly it is they are asking us to do. What do they want from us? That is the question that we really need to know. And so then the third thing we're going to do, these don't have to necessarily go in this order, these are just really important things, is we are only changing the numerator. We are not changing the denominator. The denominator stays the same because we're not changing the size of the piece as we are adding. So let's go into this addition here. It says here, select all expressions that are equivalent to 5/8. 5/8 is our target. Letter A, 1/8, 2/8, 3/8, 4/8, 5/8. That's our answer. Boom, done and done. It's just that easy. There are 5/8 here. These are all unit fractions. We're going to put them all together and we're going to get 5/8. That is the correct answer. Letter B, 3/8 plus 2/8 plus 2/8. 3, 4, 5, 6, 7. This is 7/8. So our target is 5/8. That's not a hit. 2/8 plus 2/8 plus 1/8 give us 5/8. That is a hit. 4/8 plus 1/8 give us 5/8. That is a hit. 3/5 plus 2/3 is a big no. Why is that not a thing? Because it does not have a common denominator. Now, could we determine what 3/5 plus 2/3 is? Absolutely. But we know it is not going to match here. Not a match, right? We know it's not going to match 5/8, so we don't even need to worry about it. We're going to just move on. Next, number 2. Find the value of each expression. Explain or show your reasoning. Use the number line if it's helpful. So it's kind of nice that we have a number line here. First thing we need to do, we're going to study the expression. Where do we start? When we study the expression, for a number line especially, where do we start? So we have 3 holes, 1, 2, 3, and we know we got to check and make sure this number line is cut into fifths, because sometimes they'll try to trick you and they'll cut it into something else. 1, 2, 3, 4, 5. We got fifths, so we're good there. So now we're at 3/5 here, for this is a whole number. Here's our whole number, and here is our 2/5. Here is where we're at. Now, we're going to make some jumps. We've done this before. When our jumps start here, start and go this way, those jumps are addition. Okay, and we're going to talk about a subtraction jump here in just a second. But we're going to start here, and how far are we going to jump? They want us to jump 4/5. So we're going to go 1, 2, 3, 4. Here is our ending. And so we do our jump like that. That's 4/5, 1/5, 2/5, 3/5, 4/5. Where do we land? We land right here at 4 and 1/5. That is where we land on the number line. And so we can do this another way too. We can take our addition and subtraction thoughts another step. We can decompose or break down our whole number, or we can break it down. The way we would do that with the 3 is we would know that 3 and 2/5 is the same as 3 wholes. How do I make a whole out of this? I look at my denominator. I have fifths here. So I know that 5/5 is 1 whole. So here's 1, here's 2, here's 3, there's 3, plus our 2/5, that would get me 5, 10, 15, 16, 17/5. That's my first addend. And then 17/5 plus 4/5 equals 21/5. You can answer your question as an improper fraction, or a mixed number. Either of these answers are always allowed. Either of these answers are accepted all the time. So if you like, and we've talked about this in class, how does your brain think best? Does your brain think in an improper fraction, and that's how you like to work out problems? Or does your brain think in a mixed number, and that's how you like to work out problems? Whatever your brain likes is what my brain likes, and I'm here for both, so that's completely fine. Now, for subtraction, this is really where this decompose the whole number comes into play, is when we have subtraction. When we're working with subtraction, we really have to decompose this. Now, we can use the number line. We can draw ourselves a number line. The number line is different though. Now it starts on this side. And now our arrows for subtraction are going this way because we're going backwards. So 2, now how much are we going to subtract? 1/8. We're just jumping right here. This is 1/8 right here. We're just jumping backwards 1/8. And when we count it up, now what do we have left? We have 1 and 1, 2, 3, 4, 5, 6, 7/8. 1 and 7/8 would be my answer. when you're using a number line, just remember you're going to place your first number first, and then you're going to go up or down based on the operation. So right here, for addition, we're jumping this way. For subtraction, we're jumping this way. Now, for this here, you can also do this. You can take that 2 and you can say, all right, I'm going to look at the denominator. This is eighths. I already know this is eighths. If I wanted to make this a common denominator, I could change this 2 into eighths. 1/8 makes a whole, plus, or 8/8, excuse me, makes a whole, plus another 8/8. That gives me 16/8. So 16/8 minus 1/8 equals 15/8, which is an absolutely satisfactory answer. You could also do 2 equals 1 8/8, and then you could do 1 8/8 minus 1/8. One whole number minus nothing from a whole is 1, and then 8 minus 1 8. 8/8 minus 1/8 equals 7/8. This would also be an acceptable strategy to use. You have to decide, does your brain like an improper fraction, or does your brain like a mixed number? Improper fraction and or a mixed answer, a mixed number, are all acceptable. Anytime you are able to show or explain your reasoning, so we didn't do a lot of work here. We don't have a lot of work to show. So this would be, if you got a wrong answer, I wouldn't understand what you were thinking. On the answer key, I didn't show a lot of work on this either, because on this page over here, we did a lot of addition over here with repeated addition, so 2 groups of 4/5. So that's why I didn't show a lot of work on the answer key here for that particular question. But down here, I gave you a lot of different options on ways that you can show this. You can use a number line, set 21/5 equals 4 1/5. 15/5 equals 7 1/5. Or you can take a screenshot of this right here to use to study. But either way, this is the final page of your Unit 3 study guide to be studying for your Unit 3 test of illustrative mathematics in 4th grade. All right, 4th grade, this concludes the review of the Illustrative Mathematics Study Guide for Unit 3. We talked about multiplying fractions, adding and subtracting fractions, and changing tenths to hundredths in order to be able to add those together. So if you followed through this whole study guide, you're ready. You're ready to take that Unit 3 test, whether you're in my class or some other class across the country. You are ready. So good luck, think all of the good thoughts, and I will catch you later.